We are now looking at altimeters. There is a relationship between altimeters and altitude. So altimeters are instruments used for measuring altitude, and altitude means the height above sea level. So you could as well say altimeters are instruments used for measuring altitude. Now, what is the relationship between altitude and atmospheric pressure? We are saying roughly for every 120 meters of ascending or ascent, atmospheric pressure reduces or falls by 10 millimeters of mercury. What does that mean? Each time you move 120 meters upwards, maybe you are climbing a mountain. If you had a barometer, the barometer would be reducing by 10 millimeters of mercury. The readings on the barometer would be reducing. So this means if you started with at the foot of the mountain, if you started with 760 millimeters of mercury as the reading on the barometer, immediately you move a distance of 120 meters upwards. When you look at the reading, you realize the reading would read 750, meaning that it has reduced by 10. So as you continue another 120 meters, the reading would be 740. So it will be reducing by 10 millimeters of mercury. So this gives us an impression that as atmospheric pressure reduces, altitude increases, or as altitude increases, atmospheric pressure reduces. Now let us look at the fourth type of barometer, that is the water barometer. As the word suggests, it uses water as a liquid, and we are saying it uses water as the liquid. The height of water column supported by atmospheric pressure can be worked out because atmospheric pressure is constant. We are saying whether you bring a mercury barometer or a water barometer, atmospheric pressure remains constant. For that reason, the height of water column, because this one uses water, not mercury, the height of the water column, in the mercury barometer, we're talking about the height of mercury column, but this is a water barometer. So we want to compare. If we brought a water barometer, what would be the height of the water column? And if you brought a mercury barometer, what would it be? So we are saying, we are comparing the two, that the height of the water column supported by atmospheric pressure can be worked out because atmospheric pressure remains constant. So when we say atmospheric pressure remains constant, it means the atmospheric pressure on water is the same as atmospheric pressure on mercury. So if you brought a mercury barometer, mercury being a liquid, pressure is given as H rho G. Then atmospheric pressure on water, water is also a liquid, so we shall also have H rho G. So you'll have H rho G is equal to H rho G. Now we shall make here W for water, height of water, density of water. This is acceleration due to gravity. It is constant. So there is no need of saying water because it is the same this side also. The height of mercury, density of mercury, the heights may be different for mercury and water. That's why we are making them W and M. The densities are also different because these are different liquids. But acceleration due to gravity remains what? The same. So for that reason, we shall say height of water, which is supported by atmospheric pressure, is the one we are looking for, times the density of water, which we know, 1000, times acceleration due to gravity is 10. The height of mercury supported by the height of the mercury column, if you brought a mercury barometer, it is 760 millimeters of what? Mercury. So we have to change this to SI units. The SI unit is supposed to be meters. So when you are changing millimeters into meters, you divide by 1000 times the density of mercury, which is 13,600, times 10. So when you calculate on this side, you end up with 103360. And when you calculate this side, you have 1000 times 10 is 10,000 times the height of water. Because we want the height of water, we now divide both sides by 1000 by 1000. So here our height of water is going to be 10.336 meters. which we can approximate as 10.3. So this is the height of water on the mercury barometer, which can be supported by atmospheric pressure. So we are saying a borehole, when you dig a borehole sunk below 10.3 meters. Remember, we have calculated the height which is supported by atmospheric pressure is 10.3. So if you dig a borehole and it is below 10.3 meters, it will not cause water to do what? To flow. Why? Because atmospheric pressure does not help in pushing the water. You see? Atmospheric pressure will only help up to a height of 10.3 meters. So if you dig your borehole below 10.3 meters, atmospheric pressure does not what? Help in pushing the water. So what do? In such a situation, you need a pump to force water out, because now atmospheric pressure cannot manage. So you need, that's why we are saying instead a force pump is used in such what? A situation. So in such situations where atmospheric pressure cannot help in raising up the water, you use a pump which we call a force pump.